Welcome to EDU World Space.
So problem 8.25, we have a hunter on a frozen pond that is basically frictionless. I mean, right there, you have to wonder why the hunter isn't wearing shoes that have some sort of traction with the frozen pond he's in, but perhaps he moves himself around by firing his gun, which just raises more questions. But anyway, let's take the problem at face value. So we're told his mass, the mass of a bullet, and the speed at which the bullet leaves his gun. And he's holding the gun tightly, so he and the gun will move together. And we're first asked what is his velocity from the recoil from firing the bullet when he's holding the gun horizontally, and then when he's holding it at a 56-degree angle. So now, in both of these cases, the horizontal component of the momentum is going to be conserved. So the initial momentum is 0, of course, and so his momentum backwards has to be equal to the horizontal component of the bullet's momentum going forwards, which, when it's horizontal, is the entire momentum. And then here we'll have to do a little bit of trigonometry to, get the correct components. The reason that only the horizontal is conserved is that the ice has a normal force that acts on the system, and so it causes the momentum to not be conserved if you're only considering the hunter and the bullet. If you're considering the hunter and the bullet and the ice and then the rest of the earth below that, then the momentum would still be conserved, but you'd still be doing this where you have to, take into account all of that. And then you could find out how much, what the speed of the hunter and the rest of the earth downward are, but it's going to be, it's going to be quite small because the earth is very massive. So anyway, let's get down to it. Like I said, the momentum of the hunter is going to be the negative of the momentum of the bullet. And the bullet's momentum is, of course, its mass, 4.2 grams, times its speed, which is 965 meters per second. So you can compute that, or do what I should have done in the first place, which is actually solve this for the hunter's velocity to begin with. So excuse that, please. So solving for the hunter's velocity, we have negative dp times the ratio of their masses. And then this works out to be 0.559 meters per second. So if he is using the recoil from his gun to get around the lake, he's not getting anywhere very fast. But I digress. So here we have the same story, of course. But now we have to be careful only to take the x component of the velocity of the bullet. And of course, the x component, because we're measuring the angle from the x direction, is just the cosine of the angle times the bullet's speed. And you'll note that this is just going to be this answer multiplied by the cosine of 56 degrees. Which comes out to 0.0312 meters per second.